Greetings everyone and welcome to the chemistry program. I am delighted to be here today to discuss this topic. Today I will be discussing the wonderful and marvelous world of chemistry. Today I am going to talk about electrolytic cells. Electrolytic cells and galvanic cells. Firstly, what is meant by electrolytic cells? Electrolytic cells means they are electric cells in which the electric energy from an external source is converted to chemical energy used through a non-spontaneous oxidation reduction reaction. What are the components of the electrolytic cells or analytical cells? What are the components of the electrolytic cells? The component of electrolytic cells represent that galvanic cell. In this video, we will learn that the component of electrolytic cells are a container contains electrolyte solution, as you see, like solution to any salt, acid, base, or molten of any salts. The second is two electrodes. The second component is two electrodes of the same materials, like carbons or graphite or platinum, or each one of them is of different material, like carbon platinum or copper, zinc, or others. One of the electrode is connected to the positive pole of the battery to become positively charged electrode, at which oxidation reactions occur at anode. A container contains electrolyte solution, which either a solution of any salt, acid or base, or a molten of any salts. Number two electrodes, two similar electrodes of the same material, like carbon or platinum, or each one of them different material like carbon, platinum, copper, zinc, or other metal. Number three, one of the electrode is connected to the positive pole, as we say before, of the battery to become positively charged electrode, at which oxidation reactions occurs at anode. Number four, while the other electrode is connected to the negative pole of the battery, and at which reduction reaction occur at cathode. Note that, very important note about electrolytic cells. The electrolytes which are used as ionic conductors in these cells are different from electronic conductors, which are metals. There are two kinds of liquid electrolytes. Which are, number one, the first includes the solution of acids, bases, or salts. A solution of acids, bases, or salts. The second includes the molten of salts only. When the two electrodes are connected, where the applied potential on the cell is slightly exceed the potential of the reversible cell, an electric current in the electrolytic cells flows. In this video, that illustrates the electrolysis of sodium chloride solution. Sodium chloride solution is a solution of a salt. Sodium chloride is solution is good conductor of electricity. so you can make electrolysis to it, as you see from this video. Number 4. And the positive ions, cations, in the electrolytic solutions between two electrodes are directed towards the negative electrode, which is cathode, and neutralize their charge by accepting or gaining electrons, which that is means that reduction process directed towards the negative electrode and neutralizes their charge by accepting or gaining electrons at cathode. The negative ions, which is called anions, from the electrolytic solutions are directed towards the positive pole or the positive electrode, which is anode, and neutralize their charge by losing electrons. That is means that oxidation process. Okay. For example, the electrolysis of copper chloride solution. The electrolysis of copper 2 chloride solution CuCl2, as you see in this video. First, you must dissolve copper 2 chloride in water to form a solution from copper 2 chloride. Then add an amount to a U-shaped tube to make the electrolysis to copper 2 chloride, CuCl2. During this process, you will observe that copper ions is directed toward the cathode to make reduction, to gain or accept electrons and changes into copper metal that precipitate on cathode and increases the mass of the cathode, while chloride ions is directed toward the anode up to the electrolysis of copper 2 chloride. You must watch this video well. You will observe copper metal precipitated with a huge amount on cathode, and the chlorine gas evolves, as you see. Chlorine gas evolves at anode, while copper metal precipitated at cathode. If the process is evolving gas or precipitation of a metal, this is a liberation of the component of electrolytic solutions. As you see, number 1, the anode, which is a positive electrode, UCl negative, lose electron during oxidation process to form Cl2 gas, which is evolved at anode, plus 2 electron that transfer to the other electrode, which is cathode. E node of this process equals negative 1.36 volt. Negative 1.36 volt means chloride not prefer to be oxidized. Don't prefer to be oxidized. Number 2, reduction reaction at the cathode negative electrode. Cu positive 2 plus 2 electron during reduction process to give copper metals, which is a solid substance that precipitated on the cathode and increase the mass of the cathode. Okay? And the E node of this reaction equals positive 0.35 volt. This means that copper prefer to be reduced while chloride don't prefer to be oxidized. Okay. Number 3. And the total reaction occurs in the cell is the sum of the anode and the cathode reaction, which means oxidation and reduction reactions. As you see, Cu positive 2 plus 2Cl negative to give Cu0 plus Cl2. What about the E cell? What about the electromotive force of this cell? The cell potential equals negative 1.36 plus 0.35 equals negative 1.02. Oh, the sign becomes negative. The negative signs for cell potential means here that the total cell reaction occurring is non-spontaneous if it was in a galvanic cell, but it is completed in electrolytic cell by using electrical energy from an external source. This process, in which the separation of electrolyte solution constituents is completed. Evolution of chlorine and the deposition of copper is called electrolysis. So we can define the electrolysis as you see. The electrolysis. It is the process in which the separation of electrolyte solution constituent is completed. It is the process in which the separation of electrolyte solution constituents is completed. Or the second definition to electrolysis. It is a chemical decomposition of the substance due to the effect of passing electric current in the electrolyte. It is the chemical decomposition of the substance due to the effect of passing electric current in the electrolyte. Faraday's laws of electrolysis. The scientist Faraday had summarized the relationship between the quantity of electricity and the quantity of material liberated at electrodes and the quantity of electricity in two laws called by Faraday's laws. Faraday's first law. What about Faraday's first law? What do you know about Faraday's first law? It is a very important question about Faraday's first law. The quantity of material, gas or solid, formed or consumed at any electrode is directly proportional to the quantity of electricity that passes in the electrolytic solution or molten. The quantity of electricity is proportional to the quantity of the amount of material liberated at the two electrodes. How can you verify Faraday's first law? According to Faraday's first law, we know that there is a relation between the quantity of electricity passes in the electrolyte and the amount of material liberated at the two electrodes. There is a direct relation. There is a direct relation between the amount of electricity and the amount of material. This means that by increasing the amount of electricity, the amount of material liberated at the two electrode consumed, evolved, precipitated at the two electrode will increase. Battery, rheostat, key, ammeter to measure the intensity of the electric current. First, you must clean the cathode and dry it and wet it. Connect the simple electric circuit and calculate the amount of electricity and the amount of material that liberated at cathode. As you see, by increasing the intensity I2, which differs than that I1, more than or less than, the amount of material deposits at cathode differs, as M1 over M2 equal I1 over I2. So M is directly proportional with current intensity. By a second way, we can change time. We can change the time which the current passes and measure the difference in the mass in each case. You will find that the mass is directly proportional to the time. By increasing the time, the amount of mass of the substance increases. M is directly proportional with I times T, or M is directly proportional to Q. Q is the quantity of electricity. The mass of liberated substance is directly proportional to the quantity of electricity. By passing different quantities of electricity in the same solution and calculating the ratio of mass of the formed material at the cathode or dissolved from the anode, and comparing these ratios by the ratios of the passed quantities of electricity. Faraday's second law. Faraday's second law means that the masses of different materials formed or consumed by the same amount of electricity that passes in different electrolytes connected in series are directly proportional to their equivalent masses. Faraday's second law can be expressed mathematically as the mass of the first element over the mass of the second element equals the equivalent mass of the first element over the equivalent mass of the second element. The mass of the first element over the mass of the second element equals the equivalent mass of the first element over the equivalent mass of the second element. The gram equivalent mass of the substance, it is the mass of the substance that has the ability to lose or gain 1 mole of the electrons during the chemical reaction. What is meant by the equivalent mass of any substance? The gram equivalent mass of any substance, what is meant by? It is the mass of the substance that has the ability to lose or gain 1 mole of electrons during the chemical reaction. The gram equivalent mass can be calculated as follows: equals the gram equivalent mass equals the gram atomic mass over number of charges on the ions of the element or the valence of the element. The gram atomic mass divided the valence of the element or the number of charges on the ions of the elements, which represented by Z. How can you verify Faraday's second law? Bring two different solutions, one of them copper sulfate and the other silver nitrate. Battery, ammeter, rheostat, as we say before, from Faraday's first law. The two similar electrode from copper in copper immersed in copper 2 sulfate. The two similar electrode from silver is immersed in silver nitrate. And connect the battery and connect the electric circuit. You will watch that the electric current passes inside the solutions, amount of substances formed on cathode in each cells. The mass of copper, the mass of silver must be measured. M1 over M2 equal equivalent mass 1 over equivalent mass 2. This verify the second law of Faraday. The mass of the substance is directly proportional to equivalent mass. The mass of any substance is directly proportional to its equivalent mass. By passing the same quantity of electricity in different groups of solutions to verify Faraday's second law, silver nitrate solutions, copper 2 sulfate and aluminum chloride, as you see in the video. The masses of formed material at the cathode in the cells of aluminum, copper and silver respectively are proportional to their equivalent masses. This means that the ratio Al aluminum to Cu copper to Ag silver equal 9 to 31.75 to 107.88 respectively gram. And this figure illustrates the electrolysis of different electrolytic solutions to verify Faraday's second law. Aluminum chloride solution, silver nitrate solution, copper sulfate solution. Okay. The quantity of electricity in coulomb that passed equal the result of multiplication of current intensity that used in ampere by the time in second, as you study in physics. Q equal I times T. Q means that the quantity of electricity, I means that the electric current intensity, and T means the time through which the current passed. Q in coulomb equals I in ampere times T in second. Q equal IT. I equal Q over T and T equal Q over I, as you study in physics. So 1 coulomb equal 1 ampere times 1 second. 1 coulomb times equals 1 ampere times 1 second. And 1 ampere equal 1 coulomb over 1 second. Faraday. What is the relation between Farad and Coulomb? What is the relation between them? On passing a quantity of electricity of 1 coulomb in a solution of silver ions, a 1.118 milligram of silver are precipitated. Again, on passing a quantity of electricity equal 1 coulomb in a solution of silver ions, silver nitrate that contains silver ions, 1.118 milligram of silver are precipitated. So, On passing 1 coulomb in AgNO3 solution, 0.00118 gram of Ag precipitated. 1 coulomb precipitate 0.00118 gram of Ag. On passing 1 farad in AgNO3 solution, 107.88 gram of Ag, that is mean gram equivalent mass of silver, is precipitated. 1 farad precipitate the gram equivalent mass. So 1 farad equal 1 times 107.88 over 0.00118 equals, nearly equals 96,500 coulomb. So the relation between farad and coulomb is 1 farad equal 96500 coulomb or 96,500 coulomb. As we came to the end of our program, I hope everyone found it interesting and had a good time watching us. Thank you, and till we meet again, it's a goodbye. I wish you the best of luck.